Okay, good morning. Good morning. Okay, this is Professor David J. De Los Reyes. Okay, my topic for this morning will be Autotransformer. Okay, this will now be the last transformer I will be discussing under this study of transformer. There is not so much computation regarding Autotransformer. Okay, but the main concentration of the subject matter regarding Autotransformer will be the uses of Autotransformer, advantages, disadvantages, and what is the number one important use of Autotransformer. Okay, let's proceed. The subject matter for this morning, it will be October 29. The subject matter will still be AC machines, lesson number 50. So we are almost completing 50 lessons on transformers. So we could now go around doing some calculations on transformers, and we know the concepts on how transformer works already. Single phase, three phase, the different connections. We know how to compute voltages and currents. So for tonight, I will be discussing the last topic under my AC machines. It will be Autotransformer. Okay, so this is AC machines, lesson number 50. The title of the topic will be Autotransformer, or in layman's language, so for those of you who are performing experiments on the laboratory, Autotransformer is actually, the other term is actually Variac, a variable AC power supply. An example of a variable AC power supply is this one. See this one? I'm using this in my troubleshooting for power supplies. Big power supplies of big screen TVs. So if I want to troubleshoot, okay, I want to lower the voltages applied to the big screen TV, I will just try to rotate this one. So actually, I could make the output of this one from 0 to 120 volts. Okay, 0 to 120 volts. You just rotate this one, okay, and the output will be changing. Okay, so this is an Autotransformer. So actually, the definition of Autotransformer is that the secondary voltage is actually adjustable to a certain value in which we would like to use it, right? Okay, let's try to bring out the concept of Autotransformer. The concept of Autotransformer, a portion of the winding is common to both the primary and secondary windings. Okay, let's try to bring out the winding so we can visualize it. I will be removing my chair. I might stumble on it. Okay, the winding of an Autotransformer will be this one. The complete winding from point A to point C is actually the primary winding. And the point or the circuit or the winding from point B to point C is called the secondary winding. So there is only one winding. The secondary winding is just a portion of the primary winding. So there is only one winding, and the secondary winding is just a percentage of the secondary winding, because this portion here is actually the one we are varying. Okay? As we rotate it, okay, we are changing the tapping on the secondary, so we are changing the output voltage. That's Autotransformer. This is an Autotransformer, or in layman's language, it is Variac. Okay? There is only one winding, and the secondary winding is just a percentage of the primary winding. As we rotate the knob, we are changing the voltage here is actually varying. It is variable. Variable, so the term Variac. Okay? As we rotate the knob, we are changing the percentage of the tapping connected on the primary winding. If we try to lessen the number of turns that will be rotated, of course the voltage will be less. And if we try to increase it, of course it will go bigger. So actually we could make the output of the secondary from 0 to the maximum primary voltage. Right? So if we want a 50% output of the, supposing the primary is, supposing it's 200 volts, and we want an output of the secondary to be 100 volts, right? So we will just rotate the knob up to 50%, and the output will now be 100 volts. If we try to rotate it to maybe 200 volts, 50 volts, we could do it. We just lessen the number of turns that is connected on the point B. We just, because as you rotate it, the number of turns is actually changing, right? There are some, what they call this, contacts as you rotate it. So each contact got a certain percentage, right? So for the secondary voltage, it could go from 0 to a maximum of the primary voltage. That's an autotransformer. So from point A to point C, this is the primary winding. And from point B to point C, this is the secondary winding. And this is actually variable. We got an arrow here, right? And this is an equivalent of a variable thing. This is an equivalent of the knob on the actual thing. But on the electrical side, on the circuit diagram, it will be something like this. Meaning, this portion of the winding is variable. So if this is variable, of course, the output should be variable. Okay, that's the diagram of an autotransformer. Okay, let's try to bring out the uses of autotransformer. Oh, this is just storytelling, guys. There are no computations yet. I'm just bringing out the concept how autotransformer work, right? So we bring out the concept. Okay. I said that there is only one winding. This is the primary, and the portion of the primary is actually secondary, and the secondary winding is actually variable because actually we could vary the value as we rotate. As we rotate the knob, we are changing the value of the voltage, right? Okay. Oh, this is where we bring out the voltage. We rotate it, and if you want to see that it's really changing, you put an AC voltmeter over here. So if this is energized, right, and you rotate this one clockwise or counterclockwise, you will see that the value of this one will be changing by using a voltmeter. Actually, they are doing that in the laboratory. For myself, I've done this myself because I've been through troubleshooting for many long time, you know. So I know actual thing on the Variac thing, you know. Even this isolation transformer here, when we are troubleshooting, we use this isolation transformer. We plug in any electrical gadget on this side here, and this is an isolation transformer. So when we are placing what you call this, the grounding on our voltmeter or ammeter, okay, we are safe. We are on the secondary side. Okay, we are not connected directly to the primary side because this is an isolation transformer. There is a primary and secondary which what do you call this? It's just like a firewall, protecting us from the primary just in case there is a fault on the secondary or we accidentally touch something live on the secondary. This is an isolation transformer. Okay, let's try to continue. The uses of autotransformer used to provide a variable AC voltage at the secondary. So this is actually used in laboratories, labs or shops. Okay? We use this when we are troubleshooting a certain voltage. If we try to listen the input voltage to the power supply, we use the Variac plus the isolation transformer. So we are isolated from the primary line. Okay, we are isolated. It seems there is a guard or a firewall guarding us from the primary side. So just in case that there will be something that will be happening on the secondary, we touch something accidentally, okay? We are protected because there is an isolation between primary and secondary. Okay, so the number one use is actually for variable AC voltage. Right? And number two, may be fed in reverse to step up voltage. We can also use autotransformer to step up voltage, meaning if we try to insert voltage on the secondary, of course, if you try to insert voltage on the secondary, it will go step up. The operation will be reversed. So whatever voltage you apply on the secondary, what will come out on the primary will be higher voltage. So actually, autotransformer could also be used for stepping up voltage. Step up. Oh, where's my other pen? For step up purposes. Okay. So if you need variable AC power supply, you use an autotransformer. So this is variable AC voltage on the secondary. And the other use is actually for stepping up voltage also. You insert something in the secondary, what will come out on the primary will be a big voltage. That is a step up, right? Let's try to bring out the advantages of an autotransformer. We now know the uses. Let's try to bring out the advantages. Cost less compared to the double wound transformer of the same VA rating. Of course, it's economy. We are given only one winding. It seems like if this is the core, we want only one winding, and that represents both the primary and secondary. So meaning to say, we don't have the second winding on top of it. We got only a primary winding. One winding only. And that one winding represents the primary and secondary. So we are missing some windings, so it should cost less. Right? The secondary winding, which is actually placed after the primary winding, is nothing, because the secondary winding is only a part of the primary winding. So advantages, it's cost less. Number two, the core and copper losses are lower, giving superior voltage regulation. Of course, we are only having one winding. We don't have the secondary, unlike the normal transformer, like we don't have the secondary. So of course, the core loss and copper losses will be less. And in the computation of the voltage regulation, if these two values here are less, of course, the voltage regulation should be high. Voltage regulation is actually the voltage at no load minus the voltage at full load over the voltage at full load. So if the losses are actually small, of course, the voltage at no load and at full load are almost the same. So the voltage regulation should be high. Okay? These are the advantages. Cost less, okay? And the voltage regulation should be good enough. Voltage regulation, what's the importance of voltage regulation? If we could deliver voltage that will not fluctuate down or upward it will go to a certain stable condition. Okay, our utility voltage will be fine, and customers are actually satisfied with it. So the performance of the so-called, or the importance of voltage regulation is actually, it seems just efficiency is different, because voltage regulation is actually the regulation of the voltage in which it will not fluctuate up or down. It will just uh, stay at a certain value. Okay, and this is good enough for customers. Okay, let's try to bring out the disadvantages, and this is very important. Disadvantages of autotransformer. There are advantages, like cost less, the voltage regulation is good, but there are these disadvantages which is very dangerous. Okay, does not provide isolation between primary and secondary. There is only one winding, right? And the applied voltage here is the one coming from the utility line. And there is no secondary. The secondary winding is a part of the primary winding. So it seems, if you are electrocuted on the secondary side, okay, you are directly connected to the mains, the one coming from the utility line, and that's very dangerous, right? So there is no isolation between primary and secondary. There is no isolation. There is only one winding, because the primary winding is this total winding here, and the secondary winding is just a percentage of the primary winding. If something happens on the secondary, it seems you are already connected to the primary, because the secondary winding is just a percentage of the primary winding. That's very dangerous. There is no isolation. Okay? Number two, fault at the output will affect the input, which could be dangerous. Meaning, if there is a problem on the secondary side, okay, since there is only one winding, okay, of course, the whole thing will be in disarray, right? That's the meaning of this one. Fault at the output will affect the input, which could be dangerous. Okay. If there is a problem on the secondary, assuming it's a short circuit, it seems you are shorting the whole thing, and you are connected to the utility line, right? So there's a problem. If there is a short on the secondary side, you are shorting the wire. If there is short, there should be a very, very, very big current, and that's very dangerous, right? Because there is no isolation. You are directly connected to the utility line. There's no isolation, because there's only one winding. It's the primary and secondary, and the secondary is just a part of the primary. That's the so-called disadvantage of autotransformer. But the menus, if we try to use it in the laboratory, you could obtain a variable AC, whatever voltage you want. If you want 5 volts AC, you could do it. If you want 10 volts AC, you could do it. Just rotate the knob. Just vary this one. Rotate the knob. If you want 15 volts AC, you could do it. Right? What's the proper way and how to use this autotransformer safe? It is by using the so-called isolation transformer. Okay? You must have to use this one. You plug in the isolation, the autotransformer here. This is an isolation transformer. There is a primary winding and secondary winding. So whatever happens on the secondary side, okay, there will be no problem. You are not directly connected to the mains. Okay? This is a double winding transformer, isolation transformer. There is a primary and secondary. You are not directly connected to the mains. So, for the autotransformer to be safe, you plug in on the isolation transformer, so you are on the safe side. You are segregated, you are segregated from the mains. This is the one coming from the utility line. And this is a double isolation transformer. No, double winding transformer. There is a primary and secondary. Unlike the autotransformer, there is only one winding. The primary is one winding, and the secondary is just a percentage of the primary. So it seems you are directly connected to the utility line. So For the autotransformer to be safe, use an isolation transformer. Okay, that's it, guys. I think that's the only one concept what we need here in the so-called concept of autotransformer. Okay, good morning from Los Angeles. This is Professor David General.